Hello, we are looking at your pre-calculus. This is lesson 1.3, found on page 166. It's example 1. This is talking about intervals on which functions increase, decrease, or are constant. If you look at A, and you look at that picture carefully, it's kind of like a roller coaster. You read a graph like you read a sentence. You always go from left to right. So as my eye goes from left to right, I can see that the graph is decreasing in this area. Then it tends to increase back here, and then after it goes here, it starts to decrease again. Now, when we're talking about intervals, we're talking about the x-axis. So the lowest point here, or where it changes direction, is right here. So this is considered one interval from here to here. Then from here to where it goes up, which is that, which translates to right there, this is the interval over which the graph is increasing. And then finally you have another interval here of where the graph is decreasing again. So if you'll see kind of how they describe the solution here, A says that the function is decreasing on the interval from negative infinity to 0. That means that as we go all the way from negative infinity out here, all the way up to 0, the graph was actually decreasing. Okay? It's increasing on the interval from 0 to 2. Well, we marked that here. That is from this section to this section right here, from 0 to 2, the graph was actually going up. And then again, the graph is decreasing again once we go past 2 on the x-axis. So the graph starts decreasing again, and so that interval would be from 2, and then way on here, out here is considered positive infinity. So that's why they've written this in the way they have. This is called interval notation. Okay? Now, let's look at B. We're trying to find where this is increasing or decreasing. My critical points here are going to be here at 0. That seems to be the only one. So, from negative infinity again, all the way up to 0, what is the graph doing? It's just a flat line. That's considered being a constant. And then once it reaches past this line, this piece of the interval, the graph is going up, or what we call increasing. So if I scroll down a little bit and erase this, you can see that it says, although the function equations are not given, the graph indicates that the function is defined in two pieces. This is called actually a piecewise function. You probably have seen one before, but it's just pieces of different graphs put together on one graph. The part of the graph to the left of the y-axis shows that the function is constant. So that's what I was trying to say before. From negative infinity all the way up to 0 on the x-axis, the graph is remaining constant. The part to the right of the y-axis shows that the function is increasing. And so the way that we say that with interval notation is 0, positive infinity. That means from 0 all the way to positive infinity, the graph is increasing again. All right. Now, if you want to look at checkpoint 1 here, state the intervals over which the function is increasing or decreasing. Again, the critical point, which I always try to mark, is where it changes direction. So it starts changing direction there, and it starts changing direction there. So it's increasing from negative infinity, which is way back here, all the way up to negative 1. And so if I'll notice, my graph is increasing during that span. In the middle here, the graph is decreasing. So I would write decreasing from -1 all the way to +1. That's a short distance, but that's where the graph is actually going down. And then it changes direction again at that point and starts going upward or increasing. So that interval would be from +1 to way out here, which they consider to be infinity. So the two in red here are where it's increasing, and the one in blue is where it is decreasing. Okay. Hope this was helpful.